Pluto, once held proudly as the ninth planet in our solar system, has long been a symbol of mystery and wonder. Generations of skywatchers, scientists, and everyday stargazers have looked to this distant, icy world with fascination. But now, bombshell revelation has thrown Pluto back into the limelight, and it comes from two of the most respected minds in astrophysics, Neil deGrasse Tyson and Michio Kaku. According to these leading experts, Pluto may have done the unimaginable. It may have collided with Neptune in a rare and devastating celestial event that could mark one of the most significant discoveries in the history of modern astronomy. For decades, scientific models predicted a fragile but stable relationship between Neptune and Pluto, where gravitational forces kept their orbits in a cosmic dance, seemingly choreographed by the laws of physics themselves. However, new observations and refined simulations hint that this equilibrium might have finally been broken. If true, we're not just talking about a distant astronomical anomaly. We're talking about a game-changing moment in how we understand the outer reaches of our solar system, one that could forever alter our grasp on planetary motion and celestial mechanics. Pluto's orbit has always stood apart from the other planets. Since its discovery in 1930, it hasn't even completed a single full orbit around the Sun. That's because it takes Pluto a staggering 248 Earth years to make one full revolution. Unlike the neat circular orbits traced by Earth or Venus, Pluto's path is wildly eccentric and steeply tilted, about 17 degrees off the solar plane. At certain points in its elongated loop, it actually comes closer to the Sun than Neptune. For roughly 2 decades in each orbital cycle, Pluto dips inside Neptune's path. By all logic, a collision should have happened long ago. But until recently, Pluto and Neptune managed to avoid disaster thanks to a series of delicate gravitational safeguards. One of the most important is their 3.2 orbital resonance. Every time Neptune orbits the Sun 3 times, Pluto completes exactly 2 orbits. It's a kind of natural rhythm that keeps them from ever being in the same spot at the same time, like 2 skilled dancers moving in perfect synchronization across a galactic ballroom. Adding to this cosmic safety net are phenomena such as azimuthal and latitudinal oscillation. Azimuthal oscillation keeps Pluto at least 90 degrees ahead or behind Neptune when their orbits intersect, acting like a gravitational buffer. Latitudinal oscillation ensures Pluto is usually well above or below Neptune's orbital plane. In other words, even when they come closest in distance, they're never in the same vertical or horizontal space. Then there's the VZLK oscillation, a complex mechanism named after von Zeipel, Leadoff, and Kozai that helps stabilize Pluto's oddball orbit over immense spans of time. These systems have kept Pluto on its unpredictable, yet surprisingly safe course for billions of years. But chaos, by nature, is fragile. The same forces that have preserved Pluto's orbit also make it vulnerable to tiny changes. In the late Taos or 1980s, computer simulations showed that Pluto's trajectory is inherently chaotic when viewed across long timescales. Even minuscule shifts, caused by passing objects, gravitational nudges, or oscillations, could cascade into major disruptions. These simulations hinted that although Pluto's orbit is currently stable, it teeters on a knife's edge. And according to Tyson and Kaku, that edge may have finally given way. Both scientists now believe that a perfect storm of cosmic forces might have aligned to create the first-ever Pluto-Neptune collision. Tyson, known not just for his science but also for his role in Pluto's controversial reclassification as a dwarf planet, has kept a keen eye on its movements. He's sounding the alarm, warning that the long theoretical three-body problem, the complex gravitational relationship between Pluto, Neptune, and the Sun, is no longer just a math problem. It's a real and active danger. Simulations are now suggesting that these two bodies may have crossed paths violently, ending their ancient orbital waltz in a chaotic crescendo. Kaku, famous for his contributions to string theory and quantum physics, supports Tyson's claims with theoretical weight. He proposes that if this impact occurred, it would be one of the most energetic collisions in the known history of our solar system. Given that Pluto is a small, icy world and Neptune a massive gas giant, the results would be devastating. Pluto could have been completely destroyed, shattered into frozen fragments. Neptune, though larger, wouldn't escape unharmed. Its atmosphere could be torn apart, its orbit subtly altered. The shock waves, both physical and gravitational, might stretch across the entire solar system. Even more tantalizing, Kaku speculates that this event could open new doors in fundamental physics. Under such extreme conditions, matter and energy could behave in ways that shed light on string theory or reveal new insights into the structure of spacetime. The gravitational waves from such a collision could travel through the cosmos and reach Earth, potentially being picked up by sensitive detectors like LIGO or Virgo. These waves could carry with them the fingerprints of the event, unique data that might unlock secrets about the nature of the universe itself. Though Earth is far from the icy battleground of Pluto and Neptune, we're not entirely out of the cosmic loop. Tyson cautions that our solar system is more interconnected than we realize. A collision out there could set off a domino effect. Debris might drift inward, posing threats to moons or satellites orbiting the outer planets. Slight changes in Neptune's motion could gradually disrupt the orbits of Uranus, Saturn, or even mighty Jupiter. This wouldn't happen overnight. But, in cosmic terms, centuries or millennia are mere moments. The universe, after all, doesn't rush. The idea of orbital chaos isn't science fiction. History shows that our solar system has already endured moments of upheaval. Roughly 4 billion years ago, during the late heavy bombardment, shifting gas giants may have triggered gravitational disturbances that sent comets and asteroids crashing into the inner planets. That event left its mark on Earth and may have even delivered the water that gave rise to life. Today, astronomers run complex simulations not only to monitor Pluto, but to study star systems far beyond our own, like TRAPPIST-1, where 7 Earth-sized worlds orbit in tight formation. These models help scientists understand how fragile orbital resonance really is. To Tyson and Kaku, the possible Pluto-Neptune collision is not just a cosmic accident. It's a rare opportunity. They see it as a potential key to understanding the life cycle of planetary systems throughout the galaxy. Maybe this is how many small worlds end, drawn into a gravitational rhythm until one day, that harmony is shattered. Maybe Pluto is simply the first of many. Out there in the cold reaches of space beyond Neptune, fragments of Pluto may now be drifting silently, a shattered relic of a frozen dance that lasted for billions of years. These pieces could become silent messengers, carrying with them clues about the dynamic, ever-changing nature of our solar system. Tyson and Kaku urge continued observation, not just to confirm the event, but to learn from it. Every rock, every ripple, every echo from that collision tells us something important. Space is not still. It's a living, breathing engine of creation and destruction, where stability is temporary and chaos always waits in the wings. If Pluto has truly fallen, we may have just witnessed the birth of a new chapter in the story of our solar system.